Hello friends, uh, welcome to the day 1 MS SQL DBA training sessions. So as we all know, SQL DBA is a relational database management system software and it is developed by Microsoft, and in this entire series we will discuss about each and every concept of SQL DBA concepts. So in this session we will discuss about the SQL Server architecture. Before going to that, I am introducing myself. Myself, Ravishekar. I am a database administrator, senior consultant in one of the MNC. I have total 7.9 years of experience as a database administrator. So this is about myself. So in this session, we will discuss about the SQL Server architecture. So every software it is having inbuilt, it is having a architecture. So in the same way, so SQL Server is also having its architecture. So if you see the entire diagram, if you understand this entire diagram, you can easily understand the SQL Server architecture. As we all know, SQL Server is a relational database management system software. So SQL Server follows client and server architecture. So for example, what is client and what is server? Client is nothing but from where we are accessing the application, that we can call it as a client machine. And whenever we send a request, that will be processed from the server. So SQL Server follows client and server architecture. Okay. Whenever any user raises a request from the client machine, it will be converted in the form of query in the background. That query will move from client to SQL Server in the form of network packets. Network packet is nothing but it consists source IP address and destination IP address, and whatever the data that we are requesting from the client machine, everything will be in a stored in a network packets. That network packets will be transferred from client machine to SQL Server through SNI protocol layer. We will discuss in detail about SNI protocol layer in few more minutes. Okay, so you understand, right? So SQL Server follows client server architecture. Whenever any user raises a request from the client machine, it will be transferred and it will be converted in the form of query. The query will be transferred from client to SQL Server in the form of network packets. Okay, so if we say SQL Server is entire engine, I mean this is a brief diagram, this is a example diagram, not it is not an example diagram. If we understand this entire diagram, we can easily understand the SQL Server architecture. These are the main components of SQL Server architecture. Okay, so the entire SQL Server engine is divided into two engines. One is relational engine and second one is storage engine. We can call the relational engine, also call it as a query processor. Why we call the relational engine is a query processor? Because this relational engine will process the query. Okay, so we will discuss in detail about each and every component. So whatever the query that is coming from the client machine, initially it comes to the command parser of a SQL Server. Command parser is nothing but it is a command parser. It will check the syntax errors. Okay, whatever the query that is coming from the client machine, initially command parser will check the syntax errors. If any syntax errors found in the command parser, it will throw an error. If there is no errors in the command in the query, so it will find any previously executed execution plan in the plan cache. Okay, if there is no errors found in the query, it will find whether the same query is having any previous executed execution plans are available in the plan cache. Plan cache is nothing but it is a important component in buffer pool. It consists of previously executed execution plans. Okay, so if any execution plan found in the plan cache, the execution plan will be sent to the query executor. Okay, If there is no execution plan found in the plan cache, the query will send to the query optimizer. Query optimizer will prepare a execution plan, and SQL Server will pick the best execution plan based on the response time. As we all know, for example, if we want to travel from Hyderabad to Delhi, there are multiple ways. Okay, one is by train we can go it, and by flight and by bus we can travel, right? So in the same way, query optimizer will prepare multiple execution plans, but SQL Server will select the best execution plan based on the response time. Okay, once the execution plan is selected, it will keep a copy in the plan cache for future purpose. Once the execution plan keeps a copy in plan cache, the same execution plan will send to the query executor. Okay, query executor requires some data to complete the query. Okay, it requires some data to complete the query. So as of now, we don't have any data, and we don't process any data. So query executor will not have any data. So it has to process the query. So it will ask the data for access methods. Access methods is a part of it is a component of storage engine. Access methods will ask access methods also requires data to complete the query. So in this case, access methods will ask to provide the access methods asks buffer manager to provide the required pages. If buffer manager will check whether the data is available or not in the data cache. Data cache is nothing but it is a largest component in the buffer pool. It will store the data. Okay, it will store the data. As I said, it is a temporary storage area. Under any memory pressure, this data cache will be flushed out using LRU policy, least recently used algorithm policy. The data will be flushed out. Okay, so the buffer manager will check whether the data is available or not in the data cache. If the data is available for in the data cache, the data will be transferred to the access methods. From the access methods, the data will send to the query executor. The query executor will execute the query, and whatever the processed results, those results will be sent to the client over the SNI protocol layer. If there is no data found in the data cache, buffer manager will pull the required pages from the database MDF file from the disks, and it will keep a copy in the data cache. Once the copy is placed in the data cache, the same data will be transferred to the access methods. From access methods to query executor. Query executor will process the data and send the results back to the client machine. This is how it will work. I hope everyone understand each and every component in the relational engine and storage engine component. As of now, we discussed about command parser, query optimizer, query executor, access methods, buffer manager, plan cache, and data cache, and database. So buffer pool, we already discussed. Buffer pool is a component. It consists of plan cache and data cache. Still, we have another component that we need to discuss about is SNI. SNI is nothing but it is a SQL Server Network Interface. Okay, it is a protocol layer. It will establish the connection between client and server in a different by using different protocols. As we all know, SQL Server supports different type of protocols. One is shared memory, second one is named pipes, and third one is TCP IP, and fourth one is VIA. Okay, we will discuss in detail in a few minutes. So as I said, for each and every component, I have placed the information in the next slide. As SNI is nothing but SQL Server Network Interface. Okay, SNI is a protocol layer and it will establish the connection between client and server. Okay, and using the protocols, the connections will be established between the client and server. The query is moving from client to server in the form of network packets or TDS packets as we discussed. To establish the secure connections, we are using port numbers along with the protocols. Okay, and the second component what we discussed is command parser. Command parser will basically check the syntactical and semantical errors. If there is no errors found, it will check the execution plan in the plan cache of a buffer pool. If any execution plan found in the plan cache, and it will send to the query executor to execute the query. If there is no execution plan is found in the plan cache, the query passes to the query optimizer. I'm saying if we clear about this architecture, then we can easily understand the SQL Server architecture. Okay, and the next component is query executor. Query executor requires data to complete the query. Okay, it asks data to don't have any data. It asks the data of a data cache of a buffer pool. Once it receives the necessary data and it passes to the query executor, and the results will be sent back to the user. And the next component is buffer pool. Buffer pool, it is also a very important component in SQL Server, and it contains plan cache and data cache, which is used for query execution. Okay, and the next components are buffer manager. Buffer manager is nothing but it will checks the data cache of a buffer pool to see if the data is available or not. If the data is available in the cache, data cache, it passes results to the access methods. If there is no data found in the data cache, it pulls the required data from the MDF and put it on a data cache. After that, it passes to the access methods. As we already discussed about the plan cache and data cache. Plan cache is nothing but it is a part of SQL Server buffer pool, which is used to store the previous executed execution plans in case they are needed later. Okay, and the next component is data cache. Data cache is a largest part of buffer pool. So every data page that is read from the disk, which means whatever wherever the MDF files are stored, it will pull the required pages from the disk and return a copy here before using. As I said earlier, under memory pressure, these pages are flushed from cache using LRU policy. Okay, these are the all the components, all the basic and major components of SQL Server. I hope everyone understand the SQL Server architecture. Now we will discuss about the what are the protocols available in the SQL Server. Okay, SQL Server basically supports different type of protocols. One is shared memory, and second one is named pipes, and TCP/IP. We can it is a transmission control protocol and internet protocol, and the next one is VIA, virtual interface adapter. So we will discuss in detail each and every protocol. Shared memory. Shared memory, idea of the shared memory protocol is one. It is a default enabled protocol. Whenever we install the SQL Server, by default this shared memory protocol will be enabled in SQL Server, which is used to connect the client and server if both are in the same machine. Okay, if the client and server both are in the same machine, then the shared memory protocol will be used. Just best example for the shared memory is if we go to any hotel, if we order something, they will give a print, I mean token. So if we consider as a billing machine, the application and the data everything will be stored in a that single machine. At that time it will be used in a shared memory protocol. I'm just giving an example of billing machine in any hotel. Okay, the next one is pipes. Named pipes is nothing but the client and server will connect within a LAN, local area network. For example, if we consider any MNC is having 10 floors, we can access the database server and the client application through the local area network only. For example, if I am connecting from my home, I cannot access the database server and I cannot access the application by using named pipes. As I said, it is using within the LAN, local area connection only, we can able to access the application server and the database server. So it has a certain limitation. And the third protocol is TCP IP. The ID for the TCP IP is protocol is TCP IP protocol. Okay. So for example, if we want to connect the server by using IP address along with the port number, we can able to access the client and server application by using IP address and secure port number. Okay. So here 1433 is the SQL Server default port number. So wherever we are in the world, we can access the database server or application by using internet IP address along with the port number. So here there are no boundaries for this protocol. We can access the application from anywhere. Okay. And the next one is VIA. VIA ID for the VIA protocol is it is nothing but it is simply is a wireless intranet protocol for connecting the client and server. So it is also have a limitation. For example, if we have a 10 floors of a company, okay, for example, if the Wi-Fi is connected in a first floor, if you want to the application restricted to the first floor, we can access the database server and application server in the first floor only. So it has a very limited range, so we cannot access in a 10th floor. Okay, so this is the another limitation for this protocol. So this VIA protocol has been removed from SQL Server 2012 onwards. And the next continuation for the protocols is, as I said, the default port number for SQL Server is 1433. If we want to change the port number, we can change in SQL Server Configuration Manager. In the coming videos, I will show you where to change the port number. As I said, it is a default port number 1433. If you want to change the port number, we can go to the SQL Server Configuration Manager. In that SQL Server Configuration Manager, we can go to the network configurations. Under network configurations, we can see protocols option. In protocols, if we select protocols, we can see the list of instances. We select the whatever the instance that we need to change the port number, select that instance and select the TCP IP address, where in the last we can see the default port number 1433 and where we can change the port number. I hope everyone understand the SQL Server architecture. I will attach the documentation, the complete notes of this session in the below video. Please watch it clearly once or twice. If you didn't understand, please comment it. Okay. So I hope everyone is understand. We will discuss the storage architecture in the next session. Thank you very much.